Now that we've learned limit laws, let's actually put them into practice and evaluate the limit of a complicated algebraic expression. So the directions in this case are to evaluate the limit and justify each step by indicating the appropriate limit laws. So basically we're just going to use the limit laws we learn to evaluate this limit. So the limit we have in this case is the limit as x goes to 1 of the quantity 1 plus 3x over 1 plus 4x squared plus 3x to the fourth, and all of that is raised to the third power. Okay, so the first thing I'm going to do is bring that limit inside the power. So that's one of the things I can do with limit laws. So I'm going to write this as the limit as x goes to 1 of 1 plus 3x over 1 plus 4x squared plus 3x to the fourth, all of that raised to the third power. Okay, so what can I do next? So one of my limit laws allows me to break up a quotient. So the limit of the quotient is the quotient of the limits, provided the denominator doesn't give us 0. So I'm going to go ahead and do that. So on the top I'll have the limit as x goes to 1 of 1 plus 3x over the limit as x goes to 1 of 1 plus 4x squared plus 3x to the fourth. And all of that still raised to the third power. Okay, so what should I do next? So a good thing to do would be to go ahead and break up these sums in the top and the bottom. So in the top then, I would have the limit as x goes to 1 of 1 plus the limit as x goes to 1 of 3x. And then in the denominator, the limit as x goes to 1 of 1 plus the limit as x goes to 1 of 4x squared plus the limit as x goes to 1 of 3x to the fourth, and that whole quantity is still raised to the third power. Okay, so out to the side really quick, I just want to remind you of two really important limit laws that we're about to use in the next step. So one of them is the fact that the limit as x goes to a of x just equals a. And then a very similar rule, the limit as x goes to a of x to the n, so x to some power, equals a to that power. Okay, so now I'm going to apply those rules to what I have here. Actually, first though, let's go ahead and pull out these powers, any coefficients that we have. So in other words, the limit as x goes to 1 of 1 plus the limit as x goes to 1 of 3x, I can pull that constant 3 out front and write it as 3 times the limit as x goes to 1 of x. All right, and then we'll do the same thing in the bottom. So the limit as x goes to 1 of 1 plus 4 times the limit as x goes to 1 of x squared plus 3 times the limit as x goes to 1 of x to the fourth, and that's all raised to the third power. Okay, and now we're going to apply those rules I just reminded you of. All right, so if I do that, this first thing here, the limit as x goes to 1 of a constant is just that constant. So that's just going to stay 1 plus 3. And now I just have the limit as x goes to 1 of x. So that's just going to be 1. Okay, and down here the limit as x goes to 1 of 1 is just 1 because it's a constant. Plus 4, my constant out front, and then I've got the limit as x goes to 1 of x squared. Okay, so because of these rules I wrote in green up here, I'm basically just plugging in 1 to x squared. So that's going to give me 1, because 1 squared is just 1. And then finally, I've got 3. And then same deal here, right? I've got the limit as x goes to 1 of x to the 4th. So I'm just going to plug in 1 to the 4th, which gives me 1. And all of this is raised to the 3rd power. All right, so now I just need to evaluate this number. So 1 plus 3 on the top is 4. On the bottom, I've got 1 plus 4 plus 3, so that's 8 to the 3rd power. So that's the same as 1/2 to the 3rd power, which is 1/8. So 1/8 is my final answer for this limit.